Some people call the electricity grid in Europe the biggest machine ever built by humankind. It's a huge interconnected market, Germany being in the middle of it, having interconnection in all different kind of directions. And I think this is an important element to understand European power markets, and maybe also why the UK or Irish storage market had been developing faster than the European one, but I think we have reached a tipping point now.
Peak demand in Germany is roughly 50% to 100% higher than Great Britain. So we're talking a much bigger energy user. Is Germany going to get there?
If you look at how much energy storage do we have, or battery storage do we have in Germany right now, we have 1.4 gigawatt of utility scale storage. That is 1.7 gigawatt hours. I think later maybe we briefly touch on residential as well. At the moment, we have 8.1 gigawatt of residential. And so
just to take stock on that number, that is huge, right? Is that the biggest residential fleet of energy storage in the world?
Hello and welcome back to Transmission. As a central player in the European power flow, the German energy market sits in a unique position. But how does its energy markets work? And what role does grid-scale storage have to play? In this week's episode, Lars Stephan, Senior Manager of Policy and Market Development at Fluence, joins Quentin to give us a 101 on the German energy market. If you're enjoying the podcast, please hit subscribe so you never miss an episode, and give us a rating wherever you listen. Let's jump in.
Hello, Lars. Welcome to the podcast.
Hey, Quentin. It's a great honor being on your show.
We should probably get the niceties out of the way first, which is that I'm a big fan of all the work you do. We first crossed over back in 2017 when you were at Unicos and I was at Centrica. And since then, following what you've been doing on LinkedIn, seeing some of the content you put out, I think you do a great service to the industry. And I want to say, on behalf of all of us of Modo, we're big fans and keep it up. And if you're listening to this, do check out Lars on social media. This guy puts out some awesome analysis and content.
Well, thanks for the flowers. I mean, honestly, I'm a big supporter. I'm a big fan of the German market. It's a really hot energy storage market. I'm really happy to share the knowledge about it. And I mean, it's part of our mission. The more people learn about it, the more people bring storage to Germany, the better for our energy system, the faster we can decarbonize. So it's exciting talking about these things.
And the cat's out the bag now. Everybody knows what we're going to be talking about, which is Lars is a massive German energy storage buff. And today we're going to be talking all about European energy markets and how energy storage fits into that, and specifically about Germany, which is Lars's mastermind subject. Before we get stuck in, Lars, could you just give us a quick overview of your background and how you ended up doing what you're doing right now at Fluence?
Sure. So within Fluence, I'm part of our growth team in the EMEA region. The growth team, you could say we're a bit of the Modo of Fluence, if you want to put it like that. So we're a team of 12 people focused on the EMEA region, spread out with this focus on all the geographies across Europe, looking into customer intelligence, market intelligence, guiding strategy for our company, engaging in thought leadership, marketing is part of our function. So I like to think of us as we bring intelligence and data into decision-making processes within Fluence, but also we bring this to our customers, helping them to understand changes in market environments, changes what that might mean to product requirements in the market and so on. So the motto of Fluence. And within the team, I actually wear 3 different hats. So first of all, I'm responsible for policy in the entire EMEA region. I do EU-level policy myself in the individual member states. My team members are in the lead and I'm support and guide them in their work. Then I'm responsible for market and policy development in the TSO segment. And maybe we'll touch a bit about it later because it's a big part of the German storage market as well. And then I also lead the German team within our growth team. We have 3 people based in Berlin. One of them is me, dedicated to the German market. And as you said, being the old guy with the experience, I have the honor of leading them.
And Lars, before we get started on German energy markets, we've just got I feel like it would be rude not to give a nod to the Rusco energy storage system. We both worked on that back in the day. I still, to this day, think it's the most magnificent energy storage project ever built in the world. Yeah, you were at Unicos, I was at Centrica. It was a 50 megawatt system. And you should check it out if you're listening to this, because it was built it's back in the old days. So it was built on an old coal power plant site, and it was a energy storage system in a building. None of this 40-foot shipping container stuff. This was a power station looking building, and then everything was bespoke. It was pretty awesome.
Yeah, those were the good old times, right? When we were just at the beginning of the industry and everything was way different than it is today. But I mean, it also speaks to the scaling up of the industry. So when I joined Unicos and entered the energy storage industry 10 years ago in 2014, Unicos had just delivered the first 5 megawatt project into Germany, and we thought we were the king of the world, right? Nothing like that had ever been done in Europe. And if you think about now 5 megawatt, I don't know, that's probably what we're as Fluence pushing out in half an hour or something like this. I wouldn't need to do the math, right? But it's like today you have a 20-foot container, you have my 5 megawatt hours in there. So it's, of course, the tremendous scaling and of the storage industry is huge, yeah.
Rooscote was so well, that site will be there in 1,000 years' time. It was so well built. Mark my word. Anyway, let's talk German energy markets. I'm going to do the thing I love to do on this podcast. I'm going to ask you questions like I'm a 5-year-old. So we're going to start really, really zoomed out. And this is the first, I mean, the background to this is at Modo, we're gearing up for our European expansion. We're hiring our European team right now. We've already started working on our forecasting capabilities across Europe. And so Europe is a really exciting frontier for us, and especially Germany, which is our first market at Modo to go into. And so I guess as the first podcast on the Modo podcast all about Europe, why don't we start with a big, easy question, which is, Lars, how do power markets work in Europe?
Well, I have a 5-year-old, so I should be able to explain for a 5-year-old, right? I mean, in many ways, power markets work the same way as all around the world, right? It basically splits into energy markets, which are traded wholesale, and then the products might differ, and we'll go into that probably in a moment. We have ancillary services, so all kind of system services that are procured by the system operators to make sure the system runs stable. Voltage regulation being, of course, like a key one for energy storage. But then, especially in Germany, we're going to see, or are already seeing, the introduction of other auxiliary services being available for energy storage as well. And then there's always the big question about capacity. How do we ensure the system has sufficient dispatchable capacity? Capacity markets or resource adequacy mechanisms is the choice here. And this is actually very interesting in Germany, as we are at the moment looking at the introduction of a capacity market in Germany. We don't have it yet. It will probably be introduced. I think another element for the continental European market is, some people call the electricity grid in Europe the biggest machine ever built by humankind. So if you come from ERCOT, which is of course a big market, but it's an electrical island in some ways. The UK is in many ways an electrical island. Of course, there are many interconnectors, right? But still, like it's a smaller market. Europe, on the other side, it's a huge interconnected market. Germany being in the middle of it, having interconnection in all different kind of directions. And I think this is an important element to understand European power markets, and maybe also why the UK or Irish storage market had been developing faster than the European one. But I think we have reached a tipping point now.
So let's start with the geography of Europe. In many grids around the world, there's some simple rules of thumb. For example, in Texas, there's loads of wind out west and there's loads of load on the east. Or in the UK, there's lots of wind up north in Scotland. There's constraints and there's transmission lines down south, where there's lots of demand around London and the load centres. So there's two examples of some basic rules of thumb around geography. So do you have some rules of thumb around geography in Europe?
Yeah, I think there are some, right? We have power fleets or power generation fleets across Europe have historically differed a lot. France, for example, has a very high share of nuclear generation in their power grids. If you go into the Nordic Scandinavia, you'll see a lot of hydro generation. The same in Austria, actually, and increasing wind generation. If you go to Germany, Poland, we historically had a high share of coal generation, also some nuclear in Germany, which we phased out. Poland and Eastern European states are looking to add nuclear. Italy, very dependent on gas. The same is for the Netherlands. The Iberian Peninsula, again, very dependent on gas to a large extent, but also a lot of hydro. And now, as we go to the energy transition, the question is, of course, where do we have good areas to build wind, to build solar? General logic would tell you solar in the south, right? Wind probably close to the coast. And that is also what we're seeing to a certain extent. But the interesting element is now, of course, solar prices are getting so cheap. You can have good solar yields in Sweden that allow you to achieve a proper income. So everything is getting a bit more mixed up now with the energy transition. I think another important element is interconnection between markets, because this is seen as a huge enabler of the European energy transition. When there is wind, a lot of wind in Spain, they can produce more and send it to Germany. When the wind front comes to Germany and isn't in Spain anymore, Germany will produce and send it back. And so think about Nordics as big batteries, like hydro batteries of Europe. We send electricity there. When we have a lot of solar in Germany, we bring it back in the night. So this element of interconnection is an important one. And now as we ramp up renewables, the question of how do we actually shift energy using energy storage is really coming to the forefront of our market design.
And one more question before we jump into Germany, which is, how do the grid operators or RTOs or the system operators, there's so many different words for the same thing, right? But so in the UK, we have National Grid, and there are lots of different TSOs across Europe. They don't necessarily follow the same boundaries as countries, right? So could you just give a brief overview of those and who owns the wires?
Yeah, this is a beautiful part about Europe and how it's organized, right? We have the EU level and certain guidelines about how we operate electricity grids in Europe, and certain rules how markets need to be designed are made on EU level, either by policymakers or by NSOE, the European Network for Transmission System Operators for electricity grids. And these then need to be implemented on member state level. So on member state level, typically, you have a TSO which both owns and operates the transmission grid. So we don't have like the split with an independent system operator that you have in the UK, but both those functions are within one entity. You also have cases like Germany. We have 4 transmission system operators within Germany. Normally, I think in all other European countries, we basically have one transmission system operator. And let's say because we have this bit more complex regulatory framework about what they do, I would argue processes are often a bit slower when it comes to changing grid codes, about bringing innovation into the grid, because changing European grid code is it's not a task for generation, but it will take probably 5 years from start to finish, and then it needs to be implemented. So this makes the energy transition a bit more complicated. On the other side, it also allows individual transmission system operators to come with own solutions and approaches to problems and innovate on their own turf. And this then later to be adopted by other TSOs as well.
So now on to Germany. Let's just do a quick check of some numbers. So what's peak demand in Germany, and how much generation is there, and what does the generation mix look like?
Yeah, those are great questions. And I think it's always good to start with the fundamentals. If we look at power demand, of course, it varies between summer and winter periods, right? With higher demands typically in the winter across Europe. And in the summer, we're probably talking about somewhere 50, 55, 60 gigawatt in Germany. And the winter, we get to 75, 80. The rationale of the German energy transition is, of course, as globally that we want to electrify mobility and heating. And that means that we are going to look at increasing peak demands and increasing energy demands. Just to mention one figure, because I just have in my head from the consultation, between today and 2045, when Germany has a target of achieving carbon neutral energy systems, so not power, but energy system, the demand or the energy consumption in Germany is going to double between today and 2045. And that, of course, comes along with stronger peak demand.
Wow. So we're talking like over 100 gigs of peak in Germany.
Yeah. And
by
the
2045.
keys, of course, yes, by 2045. And the keys, of course, and this really comes out when we look at the generation park that we're going to build, we actually need to have a much higher peak at times when the sun is shining. And we need to bring more flexibility to our demand. And there will be many flexibility options that we'll need for that, including energy storage. But let's look at the numbers on the generation side. So in Germany, of course, we have phased out our nuclear fleet. I think that is well known. We don't have nuclear anymore. We still have around 36 gigawatt of coal generation in the German grid, and I think roughly the same around gas generation. But we, of course, want to look into renewables, right? So on the renewable side, today, Germany has 88 gigawatt of solar. We have around 62 gigawatt of onshore wind, 9 gigawatt of offshore wind. And these wind and solar is, of course, going to increase. And I'll tell you some numbers in a moment. But just to recognize, we also have 10 gigawatt of biomass and 8 gigawatt of hydro, which is interesting because this is 18 gigawatt of basically renewable baseload generation, which is often like neglected. But this is, of course, also in the system. All right, so let's turn to our targets. What do we want to achieve by 2030? 2030 is the target when Germany wants to have 80% of renewable penetration in the power system. Today, we have 52% renewable penetration. 2030, we'll get to 80%.
And just on that, is that on volume? That's on terawatt hours?
Yeah, that is on volume, yeah. And so by 2030, we're going to ramp up the German solar fleet from 88 gigawatt today to 215 gigawatt. I mean, at the moment, we're building, last year, I think we built around 15 gigawatt of solar. And the plan is by 2030 to basically build between 15 to 20 gigawatt of solar on an annual basis. And I mean, just imagine you build 15 gigawatt of solar in a year and then the sun is shining, what that means for what's happening in the system. On the wind side, today we have, as I said, 62 gigawatt of onshore, and we'll bring that up to 115 gigawatt of onshore. And we have 9 gigawatt of offshore, and we want to bring that to 30 gigawatt of offshore. So we're really seeing a massive integration of renewables. And now in the electricity market design, really the key questions are, how do we incentivize those renewables to come into the grid, into the right locations? Because just having renewable generation doesn't mean we can bring them to the load. And how can we better balance out the generation and the load in the German energy system?
The scale of these numbers is huge. Just to put this into perspective with some, I mean, Great Britain and the UK is going through massive change as well, especially with we've got a new government and things seem to be moving quicker. But peak demand in Germany is roughly 50% to 100% higher than Great Britain. So we're talking a much bigger energy user, which I guess with the amount of manufacturing and industry in Germany, that sort of makes sense. And then the scale of the decarbonisation efforts, some of these numbers are truly, truly fantastic. And so the question is, well, so many questions about this. Is Germany going to get there, and who's going to pay for it?
These are the questions we're asking ourselves at the moment, and where we actually have government consultations out that will change key fundamentals how the German market works. I think one key element is the grid build out in Germany, because it's very similar as in the UK, right? The best wind resources and of course offshore wind resources are in the north. Many of the load centers are in the south. We have one price zone. That means we need to build transmission north-south at a really high cost. And at the moment, there's a question, should this cost for grid build-out, which will take place over the next 20 years, but then the assets will be used for 60 years? Should we put this cost on people now for the next 20 years? Or should we have a government fund and spread out this investment into the grid cost over the longer period of time, realizing the energy transition is a fundamental change and it's investment in infrastructure? And is that a way to keep energy costs low in Germany? So I think the grid element is one piece, and German grid operators are actually quite innovative, bringing in new technologies. We have huge batteries being used to reduce congestion on the German grid, those so-called grid boosters. So we're doing a lot there already. The other question is really, renewables are producing when the wind is blowing, when the sun is shining. And as in the UK and Germany, we're seeing increasing numbers, record numbers of negative prices in the wholesale market. And at the moment, renewables are incentivized via feed-in tariffs by energy produced. So it's kind of produce and forget scheme, which is of course not fit for the future, where renewables also need to take a stronger responsibility to produce energy when it is needed. And energy storage, shifting renewable energy production around, will be a big portion of that. And at the same time, we need to get to a point where consumers and industry actually starts using energy when it is there for very low cost, and not use it when we actually have to fire up gas plants in future in Germany powered by hydrogen, because that's their demand. So there's this huge challenge with really many major topics that we need to address about designing an energy system for the future.
All right. Now we're going to switch focus to batteries, which is, of course, what we love talking about. So what is the need for batteries in Germany? and how much energy storage is there already installed, and how does it make money? So we're going to try and cover those questions. So let's start with the need. Is there a geographical need? Is there a certain number of gigawatts that the government is looking for? How do you define that number? And then let's talk about how these batteries are going to make money.
Yeah, that's a great question. And maybe to even take a step back, I think the great thing about the need for energy storage in Germany and for the storage market in Germany, that it's fully driven by fundamentals of renewable generation. That means we have very, very deep market opportunities for energy storage and energy trading and in balancing renewables. And this is encouraging in a way that the German market is not based on central procurements, not based on narrowly defined markets, for example, in the frequency relation space, but it's driven by fundamentals of renewable integration, which requires batteries. All right, so let's go to the numbers here. If you look at how much energy storage do we have, or battery storage do we have in Germany right now, we have 1.4 gigawatt of utility scale storage. That is 1.7 gigawatt hours right now in Germany. I think later maybe we briefly touch on residential as well. At the moment, we have 8.1 gigawatt of residential, and that represents 12.7 gigawatt hours of residential. So
just to take stock on that number, that is huge, right? Is that the biggest residential fleet of energy storage in the world? Something like that.
Definitely in Europe, probably in the world, yeah. And this is a special element of the German market as well. But let's now, for now, focus on the utility scale. So we have 1.4 now. Now, what is a target? How much do we need? One issue in Germany is that we in the market actually lack transparency about what is an interconnection queues, what are plans. You hear from people, but like real numbers can be difficult to come by. But I brought some for you anyway. So energy storage projects that go online in Germany need to register with the regulator. That's where we get this 1.4 gigawatt from. They can register if they're under construction. Not everybody does that, but they can. So projects registered at the grid operator to come online by January 2026 are at the moment at 2.5 gigawatt hours. That's utility scale. So we have 1.7 gigawatt hours right now. In the next 18 months, minimum 2.5 gigawatt hours will come on top. So, I mean, that is already where you can see that we're really ramping up in a fast acceleration. Now, where do we go from there? Earlier this year, we commissioned a study with Frontier Economics, and they run the economic model. And they said by 2030, the German energy system could have up to 15 gigawatt and 57 gigawatt hours of energy storage being driven on a market basis in the German system. The great thing, it reduces cost to consumers. It reduces the need to build out more gas peakers, and therefore it reduces CO2 emissions. So really the benefits energy storage brings to energy systems.
And just to clarify there, you're saying by you guys commissioned a report, by 2030, there's going to be 15 gigawatts of energy storage, you reckon? But is this all front of the meter? Is this on top of all that behind the meter that you've got?
Yeah, this is all in front of the meter. And maybe to go a step further, which is like a number that the German system operators or the German TSOs came up with. So in the network planning process, they basically need to say, what will the energy system look like in 2037? And they say in 2037, so 13 years from now, Germany would have, in the central scenario, 32 gigawatt of energy storage with 64 gigawatt hours of energy storage.
Wow.
And this is just utility scale. For residential, they forecast around 55 gigawatt and around 140 gigawatt hours to come on top of that. So huge potential, very exciting.
Yeah, so you're looking at many years of doubling capacity essentially there to get there. And we're going to talk about the residential fleet later because, that is a really interesting part of the market. And then what does a business case for batteries look like in Germany?
Yeah, this is a great question. And it depends a bit on which business case we're talking about. So maybe I can first touch on the fact that we have kind of three very distinct segments of in front of the meter utility scale storage in Germany, which I think is pretty unique on a European perspective as well. So first of all, we have assets which are built, owned and operated by transmission system operators. And they use those assets, no market interference whatsoever, but they use that to increase the line rating of the transmission grid. I like to compare it as an airbag to the transmission grid. They use the lines to a higher capacity than they usually would And if they have a fault, the batteries jump in as an airbag. And of these, we have at the moment 450 megawatt spread over 3 projects for Transnet BW and Tenet under construction in Germany. Those are actually constructed by Fluence, so we won those projects. And in the last network development plan, a third German TSO called Amprion got the confirmation that they can build another 500 megawatt of grid booster assets, and they are starting the procurement of the first one this year, the next one next year. So there we have 950 megawatt of storage owned and operated by the TSOs. I think don't really have that elsewhere in Europe. Owned and operated, maybe with a little question mark, because the Amprion project will try to combine rate-based revenues together with market-based revenues, and we'll have to see how that pencils out in the tender. The second segment that we have is around co-location. So in Germany, we have a specific state-run auction for co-located assets. So it's solar assets, and if those solar assets have batteries attached to them, they can get an increased feed-in tariff. And under this scheme, until today, around 820 megawatt of storage has been awarded. Those are typically 2 to 3 hour assets. So around 2 gigawatt of energy storage awarded on that scheme. And based on current government plans, until 2028, another 1.5 gigawatt of storage will be awarded under this mechanism. The interesting piece about this mechanism is you get 20-year guaranteed feed-in tariff. So it's contracted revenue all the way, which can be very interesting. On the other side, it has to be co-located. System sizes are typically smaller. So in the TSO space, we talk about 100 megawatt, 250 megawatt assets. Here we're talking about anything from 1 megawatt to 10, 15 megawatt. Still, an interesting market segment that I think we don't have elsewhere either. And then we're really talking about the bunch, which will, like the biggest segment, which is the market-based assets, right? Which we see in other markets around the world. So here we have utilities as investors, energy storage investment funds coming in, renewable developers, traders being interested to have this flexibility in their portfolio. Yeah, and this is really the largest segment, which will take the majority of the storage ramp up.
And this is the lion's share of energy storage will be unsubsidized, market-based, which in British parlance would be kind of a merchant model, which is taking advantage of deep wholesale market spreads and build the asset and make money from spreads rather than subsidies or anything else.
Yes, exactly. So these assets, as you say, fully merchant, they will realize the revenue in auxiliary service markets like the primary frequency, secondary frequency relation in Germany, which are both auctioned on a day-ahead basis. So there's no contracted revenue in there whatsoever. And then trading energy on the day-ahead markets, in intraday markets, continuous intraday markets, where really the volatility in the energy system from forecasting errors that materializes in the continuous intraday market. So this is where those assets will come in, earn the revenues. There are very interesting things to it, how the market clears. We talk about these assets that in the continuous intraday market, they can trade up to 10 to 15 times amount of energy and collect the spreads from it than what they actually physically dispatch in the end. So it's very interesting because battery is being used as a hedging tool for energy traders. So on the one side, we have the fully merchant nature, but on the other side, and I think this is in the UK, you just had those giant offtake agreements. And when I talk to people in the industry, traders will tell me, I want flexibility in my portfolio. I will pay you an annual PPA rate. I mean, all the kind of commercial offtake structures and agreements that you could think of are in theory in play in Germany as well. I think we're going to see more and more of those as all of these projects, which are currently under construction, are actually built in the market.
Yeah, it's a crucial point there, which is that, and we should probably do a podcast on this itself, which is that having an asset in your portfolio, asset-backed trading means that it's almost a way to get leverage using the asset. It's a way to think about it, which is quite different to many markets around the world. The asset gives you access to wider generation streams, regardless of whether you run it or not. And so that we should probably do another podcast on that at some point. Let's just a brief overview. So we talked about wholesale markets, we talked about frequency response, and there's some other revenue streams coming down the way: inertia, black start, voltage regs, all of that stuff, and capacity market, of course. Could you just talk about what the revenue stat looks like if you're building a battery What generally do you assume about the future? And this is a dangerous game, but of course. But generally speaking, what does your Excel spreadsheet look like?
It is a dangerous game to tell you about my Excel spreadsheet for sure.
Also, doing a podcast about Excel spreadsheets is a way to get everyone to switch off right now. If you're still with us in 10 minutes' time, you're a legend.
No, I'm not going to talk about Excel spreadsheets. So again, like an issue in Germany is we don't have the kind of transparency that we see in other markets brought in by people like you, right? There are, of course, reports by consultancies about how the revenue stack looks like, how it's going to continue going forward, what revenue numbers are. There are also some UK-based energy storage investors who actually report about the revenue that they generate with their assets in Germany, and that can also be somewhat an indication. So it is difficult to say, but when you talk to optimizers, for last year, they will give you numbers of revenue for a 2-hour asset per megawatt of north of 200,000 euros per megawatt. This is last year, where we had stronger volatility as well from the gas crisis still. On the other side, beginning of the year was slower. The summer has brought up back a lot of volatility in the market. So other numbers from an optimizer, they're claiming that in May, they could have realized a revenue of 38k per megawatt just in 1 month. And in June of 19k per month. Do I necessarily trust those numbers? I'm not necessarily sure. There's probably a lot of marketing in there as well. But I think you can definitely say, if you look into your Excel sheet, you will see the business case in Europe. If maybe take a step back perspective, when we look we have our Excel sheet, right? And we look at different markets across Europe. There are markets in Europe which will bring you a higher IRA. There are definitely markets which bring you a low IRA. And feedback from the market is, at the moment, probably mid-teen double digits are there. Maybe sometimes a bit lower. Others will come up with, I heard somebody's talking about 25% IRA, which I don't necessarily think so. I think there are a lot of risks and details in how you build your German business case, which foreign investors often don't know or don't understand, so they don't recognize them from the start. But I think an important element, if you look at the business case here, my summary would be, you can make good money in the German market today. The outlook is good because the earning potential is based on fundamentals. It is based on deep markets. Of course, there will be certain kind of saturation. At the same time, the more renewables we build, the larger gets the requirement for more flexibility in the market. So there's always a potential of setback of revenues, as we see in other markets this year, for example. But generally, I think Germany is a very, very good and safe investment for energy storage. And this is, of course, before potential future contracted revenue streams might come on top.
Well, we're not going to be able to dive into all of them, unfortunately, but can we just talk about the capacity market process that's happening in Germany right now? What's going on with that?
The industry has asked itself that question for a long time because the policy process hasn't been as fast as it should be. So maybe start from the beginning. We are phased out nuclear. We want to phase out coal latest by 2038, earliest by 2030. If we take all of that dispatchable capacity from the grid, we have 36 gigawatt of gas left. We need dispatchable capacity. Germany always had the idea of an energy-only market design, like ERCOT. Scarcity pricing will incentivize investors to build assets with long investment timeframes. Then came the energy crisis. Policymakers interfere in market price setting, not really helping creating certainty, right? At the same time, Germany wants to build gas assets, but those should convert to use hydrogen going forward, which makes things again a bit more complicated. At the beginning, the German government had the plan to have an auction for around 25 gigawatt of gas peakers, which at a later stage should turn into using hydrogen as a fuel. Then came a famous decision of the German Constitutional Court, which said the financial workings in the budget are not legal, and the German government all of a sudden had to come up with how to fill a 60 billion gap in the German budget, and that plan was basically shelved because, hey, building gas peakers is probably not the most efficient and cheapest way to procure capacity, right? So the plans at the moment
Well,
is...
especially when, just got to call it out, especially when you're assuming there will be a switch to hydrogen without all of the other stuff you need to make the hydrogen work.
Yeah. Well, the good thing is, for running on hydrogen, they will get a subsidy on top of subsidies to pay for the spread between the gas price and the hydrogen price. So not quite good for the German federal budget, I would say. Anyhow, so
good for whom? Yeah. Anyway,
let's discuss that in another podcast as well. So the plans now is to build 15 gigawatt of gas peakers right now, which should part of it be remodeled to burn hydrogen, and then to establish a capacity mechanism. We had like a stakeholder process ongoing in Germany for more than 1.5 years, not just about this, also about how to incentivize investment in renewables, how to bring local signals and flexibility into the market. But let's focus on the capacity market piece. So there was a stakeholder process, and they came up with 4 options. The German government now started consultation about 2 weeks ago, where they outlined those 4 options and said what option they prefer. So the options are first like a scarcity price hedging requirement for traders. I would kind of compare it maybe to resource adequacy mechanisms in CAISO, where load-serving entities need to hedge assets. The next option is a decentral capacity market, as we have it in France. And as I think about it, probably CAISO is more like a decentral capacity mechanism, because load-serving entities would need to show that they have contracted sufficient amount of dispatchable capacity. The third one is a central capacity market, like we have it in the UK, Belgium, Poland, Italy. So a mechanism that we know in Europe and has been implemented in many countries. Germany wouldn't be Germany if we wouldn't go a different way. So the idea that the German government favors is a hybrid model of a central and a decentral capacity market. So they want to split up the capacity requirement. Let's say it's 80 gigs. They want to split up, put, let's say, 15. So those numbers, I just come up with them, right? Let's say 15 are being put in a central capacity market. These will be for new build assets, potentially gas peakers. Depends how that is defined. And the remaining capacity has to be procured via a decentral capacity market mechanism. So if we look at the role for energy storage in here, first of all, a good thing is the government has recognized from the start that energy storage will play a role in the capacity mechanism. They also outlined that decentral capacity mechanisms or hedging models are per se better for energy storage, and that central capacity mechanisms, and of course especially derating factors, have the risk of undermining the role of storage, but also other innovative technologies, and thereby push them out of the market. Because if you think you're incentivizing a lot of flexibility into the market, subsidized, plus hydrogen subsidy on top, what is the role of energy storage? So the government is very outspoken that these are the risks. We don't know yet what the final design will be. The expectation is then in October, a decision will be made and legislative procedures will start. As the government is clearly outlining the need for energy storage and the hurdles that energy storage can face in a central capacity market mechanism, my expectation would be, if we know what can go wrong, let's not go wrong, but let's think in a clear way about what a derating mechanism or factor, for example, should be for storage in that market.
And if I ask Lars Stephan, not Fluence, but you, Lars Stephan, what's your favorite?
Oh, that is a difficult one.
These are not the views of your employer, of course.
Well, I can also tell you the view of Fluence as we're currently actually setting up our positioning and our framing of that. And it's basically irrespectively of which solution will play out in the end, it needs to be clear that the role of energy storage is strong in the capacity market mechanism, because storage replaces gas peakers, it makes it cheaper, it makes it more carbon neutral, right? We reduce emissions. So there's nothing to lose by having a strong role of energy storage in the capacity market mechanism. I typically believe if other markets have done things and we can copy from them, that is probably easier and is more failure proof than inventing our own thing. So in that sense, that would indicate maybe a central capacity mechanism could be a way to go, just because we have a lot of international best practice on it. On the other side, having a hot hedging model which industry stakeholders see at the best option for flexibility, not just storage, other flexibility, is also quite interesting. So I'll see where we go with it.
I think it's really interesting what you just talked about there, because the German economy is so, and quite rightly and proudly, based on building things, right? It's a nation of production. And so therefore, baseload energy prices have got such a big impact on the economic future of the country. And so it really is important that whatever is done, however the market is designed, Germany can still be globally competitive in manufacturing and industry. And so the cost of all these things really, really matters. It's what I like about it, and having done, the last 6 months looking at the German market in detail, is that the German government is really thinking carefully about what kind of solution it wants in a cost-effective way to the Dunkelflaute or other big system problems related to high penetration of renewables. I think I actually agree with them that, and this isn't a very popular take, but I think gas peakers are a good thing for energy grids in general, and a way to incentivize gas peak efficient gas peaker growth is probably a good thing for the next 20 years or so. But yeah, there is the H word everywhere across German legislation and German policy about this. Well, I'm not sure how that's ended up happening, but I think that could end up making all of this very expensive.
Yeah. I mean, I think German energy system was always built around the idea of gas, cheap Russian gas, as a bridging technology. So politically, I think the message of just use a different kind of gas, we'll import it from somewhere, is easy. Of course, we have strong stakeholders who builds those plans, who operates those plans. And I think a key change was really the budget constraints that Germany is facing, the focus on cost, and realizing, you know what, actually doing the same old thing just with using a different fuel is maybe not the best solution. And we should really embrace the potential that the energy transition brings with us, new technologies that come in, bringing more flexibility into the system. Again, not just utility scale storage, there will be a huge and important part, but also all other kind of flexibilities. This is really being more embraced right now. I think we can learn a lot from the UK if you think about dynamic tariffs, dynamic retail tariffs, and grid fees and so on. Yeah.
Let's just talk behind the meter for a second. You can't get your head round the German power system without taking note of the growth in behind the meter. And it's also a bit of a political hot potato as well, isn't it? So what's going on with behind the meter batteries and behind the meter solar?
Yeah, this is a great question. And as we said before, Germany has the biggest residential market in Europe, maybe even the world. So the question is important. In a German discussion, you could even add on top the role of electric vehicles, vehicle to grid. My short answer is I don't think it will have a major impact on the business case of front of the meter storage, but let's dive a bit into it. So yeah, German storage residential market is big. We talked about the numbers before, right? Around 55 gigawatt by 2037. I think when we talk about the integration of those very decentral assets, we have to consider a couple of things. I think first there are technical elements. The controls of it, the metering concepts, measuring rules is actually a huge issue at the moment. Measuring rules, how do you meter solar generation in the battery and electricity from the grid, which is not allowed at the moment in Germany. I think cybersecurity will more and more come in as a major roadblock as well. Bringing all this energy from the low voltage into high voltage where it might be needed might be a challenge. So I think there are these technical elements. On a market side, I think it's really about opportunity cost as well, and understanding the willingness of using residential batteries to what kind of purpose. So you have a residential battery because you want to increase your energy autarky with the solar on your rooftop, right? You don't want to have a battery to discharge it in the evening when electricity prices are high. And by the way, that would also be a bad deal because you use the battery to optimize against retail tariffs, which are just very high. That is why we have those many batteries in Germany. So there's a question also, what is the marginal cost of providing a service from a residential battery? It will be cheaper from utility scale storage. Then market opportunity, which markets can you actually dip into? You will not be able to provide black start services from decentral fleet of residential batteries. I can never believe a TSO would sign up to something like this. Same thing, inertia, frequency regulation. I think there are certain procurement preferences of TSOs as well. This being said, I think residential batteries, EVs, will play a big role. And this is really about smart charging, about charging up. For example, when we have a lot of wind in the system, the batteries in the winter, there's no solar. They'll probably be empty. We have a lot of wind in the system. They should take up this wind power, right? They can help us prevent curtailment. They can help us integrate renewables. And I think this is probably the role that these more decentral flexibility assets in the German grid will take going forward.
And finally, I want to talk about accessing the market. So there's a few different models. So in the US, there's a lot more vertically integrated asset owners and operators, IPPs, and the optimizers are starting to be formed and do what optimizers do, which is the promise of making more money in the market and taking a cut of that bit more. And the same thing is started, of course, in the UK, we've got a very mature optimizer market, and the same thing is starting to happen in Germany. Am I right?
Yeah, you're absolutely right. I think this is also an element of this acceleration of the German storage market right now, that a lot of new actors, which we didn't have in the market before, are entering the market. Project development in Germany, not easy. Getting grid access, getting planning permit. I could really dive into that, how complicated that is, how you need to be able to speak German, how you need to be forward thinking in order to actually get your approvals from those authorities. Very complicated, technical rules, very complicated. So we see dedicated storage developers entering the German market. We see, of course, the existing utilities who operate assets in the market today becoming active. For them, especially utilizing their brownfield sites where they have existing grid interconnection, former nuclear power plants, former coal plants, is very attractive because they don't have to worry about getting interconnection. And we, of course, also see optimizers, and especially this intraday optimization using the battery, what we mentioned before, virtual trading and continuous intraday markets. This is a skill set that the big traders don't have from the start. So those optimizers are bringing those skill sets to the market. On the other side, I said before, like the big traders can use batteries in a different way. In the end, energy storage is being used to balance against forecasting errors in renewables. You can do that either via the market, where an optimizer will put storage in, or you can do that if you have a large portfolio of renewables within your portfolio. Because if your portfolio runs an imbalance, you have to pay hefty fines in Germany. Another element, if you have a big portfolio, you have gas assets in there, you can actually use the battery not just as a physical hedge against forecasting error of renewables, but also against price spikes in the gas market. Because maybe you say, oh, tonight the gas price, spot price is really high. I use the battery instead of ramping up my gas power plant. So in that sense, it gets very interesting because big traders use the battery as a hedge, not just in the electricity market, but also energy markets and in a wider sense. And at the moment, we're seeing all of those players emerging. We see a big inrush of investors in the German market. And if you would ask me, what is my advice to investors entering the market? It is really understanding that the market is very complicated. If you make the wrong step at the beginning, your project might be sunk already. You need to understand a lot of local rules. And that's probably the same in every market which you enter, right? I guess Germany is a bit special because we speak German in Germany. We don't speak English, right? We have 800 distribution grid operators in Germany. Everyone can make their own rules to a certain extent. So there is complexity in there. So what we see is that investors are looking to de-risk their projects. We see a lot of requests for EPC offers because they don't want to own that interface between the EPC, balance of plant, and product company. So working with companies who have been in the market for a long time, who know the ins and outs of the market, is really something that is driving value and de-risking market entry into the German market.
All right. There is so much we could have covered in this podcast, and we've only just scratched the surface. So maybe we do this again in the near future and dig down on some of those revenue streams. But now, Lars, on to the last two questions. The first is there something you want to plug? Anything you want to talk about to our listeners?
Yeah, I think so. So we haven't talked a lot about Fluence yet, and I think there is some element I would like to dive a bit into. It's about total intelligence of energy systems, which is really for us about driving value for our customers. So as energy storage and also renewables become more and more complex, we believe that understanding, owning, and leveraging data that you have from your assets, both when you build it, when you operate it, end of life, when you manage them, that this can drive great value. It is what we believe in as Fluence. So in our newest product generation, for example, we extend our reach in the data side. The GridSec Pro product line, we're integrating the Fluence pack, in which we buy battery cells, build our own modules, we put our own BMS on it, and basically using all of this data to drive better results for our customers. A couple of weeks ago, you had my colleague Gary here talking about the AirKit market, and I think you touched a couple of other markets. And you also talked a bit about the role of knowing what the market is doing and knowing what your asset is doing at the same time to be able to generate more profits from it. And there are a couple of other examples. For example, our asset performance management software actually comes from wind and solar. And there we have this. I mean, when you listen to the guys, it's really exciting, right? Or very interesting for me, at least for you as an engineer probably as well. They see data points in a windmill, for example, thousands of data points every second. Everything is working fine, but they see there are a couple of data points which are not there where they should be. So they send down the maintenance crew because they know if this happens, in 2 or 3 weeks' time, we'll have a fault. So the ability to have preventative maintenance is, I think, a very interesting one. And also understanding asset performance from cell to interconnection really allows you to better manage, optimize, use the asset, both in a way, for example, to know, hey, maybe today I can run a third cycle or a fourth cycle with my battery if the revenues are there, which I think is very exciting. For us, it also means having better degradation curves and OEM warranties based on the data and our knowledge about assets that are operated. And I think going forward for the storage industry, this element of data-driven intelligence that span the whole lifetime of the asset, I think this is something that will come more and more into the focus. And yeah, we're just very excited about it at Fluence.
Awesome. And now onto your contrarian view, Lars. I'm sure you've got loads of them. But what do you believe that perhaps the rest of the world doesn't?
Yeah, I have one, and I'm interested to see your reaction to it. It is not about Germany, but about more Europe. So I think Europe will see the emergence of an energy storage market that is focused around manufacturing and value creation within Europe by European companies. And this will be driven mainly by policy action from EU policymakers and under a lot of action, which will all come under the umbrella of the European Industrial Deal. And they'll probably be focused around things like cybersecurity, ESG, end of life, technology innovation that can be driven by European companies. So that is my contrarian view. I can tell you also why I think so, if you're interested. So, yeah, I think there is some writing on the wall, right? So in some ways, it would be a replication of what the United States are doing with the IRA, bringing clean tech manufacturing into your region. Now with the Ukraine-Russian crisis, I think resiliency of your supply chain has become a value in the policy space and also towards renewables. I think there's probably a question, does it make sense to onshore solar production in Europe, which is much stronger commodity? But if you think about energy storage, apart from the battery cell, which is also coming to Europe, the manufacturing, I think we're not talking about a commodity, but about an area where European manufacturers drive value. I think we have a couple of legislative items out there already, like the Net Zero Industrial Act, which will allow higher prices to be awarded to assets which have higher sustainability ratings and which have higher resiliency ratings, basically saying assets which are not produced in a country where more than 40% of the supply chain is based. I think we all know what that means. We see in other parts in the energy sector already a heightened scrutiny on the topic of cybersecurity. We had it in Europe on the telecom sector. Actually, I don't know what the UK position is, right? But the whole question is which companies from which parts of the world are allowed to put infrastructure, critical infrastructure into our society. It applies to telecoms. I think it's not a huge step to think about critical infrastructure, power infrastructure. So cybersecurity is already on the agenda. I think it will become stronger. And in the end of the day, look, energy storage is a huge investment opportunity. Let's not forget that, right? So I think European policymakers will want to bring this investment opportunity into Europe. And we're actually seeing, if you think, I don't know if you heard, but the European Union has put tariffs on EVs from certain manufacturers or certain countries. So there is a much more willingness. Well, the official wording is, I guess, fight against unfair competitive practices. But there is a much stronger willingness to engage in industrial policy. And I think we're going to see this coming down the road. And it will be interesting for us as a company going through that, of course, but also for investors in energy storage. And what does it mean for an investment today? How do you make it future-proof? So many exciting new dimensions, I think, to the energy storage sector.
Yeah, now, so I got this unusual perspective now. I live in the United States, but spend a lot of time in Europe with work. And the impact of the Inflation Reduction Act and the policy directive of industry being brought back home, in inverted commas, to the US is remarkable. Not only in the economic impact, but how it changes sentiment. I've really noticed that. And I think there's so many things now that Europe has deindustrialized on. I mean, even defense, right? It would be great if Europe could stand on its own 2 feet, especially as there's pressure on NATO and all of that. And I think that's one area. Manufacturing and net zero, which is such a huge, there's going to be an influx of capital. Europe needs to move quickly and build that base in-house, if you like, on continental Europe. And I really hope they can do it. I think Europe's been told it's the ugly brother for too many years now, and it's fed up. And Europe has got incredible people, incredible countries. It's a safe place for assets and capital and has been for hundreds of years. And I think now is the time that it will get itself into gear. So I actually agree with you, Lars. I agree with you. But the problem is...
That's not contrarian then. No.
Well, yeah.
We agree, the rest maybe not.
Aren't we? We're geniuses. Everyone else is not. No. The problem is, though, it all depends on an energy cost base, right? Because if you can build stuff in China for half the energy cost and the carbon market works, let's say, differently, then how do you compete globally? So making these, it comes back to the point that making these policy decisions, like Germany's doing right now, have huge impacts on the whole industrial base.
Yeah, I agree. But I think, if we look at it, when we listen to our customers, they will tell us European supply chains, it depends on the value, and it can constitute a premium on the product, but it needs to be driven by value. But now if you think about safety, that has a value. Are we willing to pay more for safety? Yeah, probably. Technology innovation, having jobs here, having this kind of resiliency of our own supply chain, cybersecurity, I think we are understanding again that these are values for us as a society and our energy sector. And so I guess it's probably the question, how do we internalize these values into the markets? And I think that is probably what the European Union is going to do.
All we need is stickers, Lars. Now I live in Texas, right? Everywhere you go, you buy anything. You go to Home Depot or you go to Walmart or whatever. And there's stickers on everything that say made in USA or made in Texas. And they just get stuff off the shelves. People want to buy that stuff. But anyway, we've digressed. Lars, I want to say a massive thank you for coming on the podcast. If you listened to this and liked it, you should check out Lars's LinkedIn. Also, see what Fluence are up to. We should probably give a nod to Fluence, seeing as you work for them. And do follow Lars and check out his analysis on the German market. It's very, very good.
Well, thank you. And I'm already looking forward for you coming to continental Europe with your services, for sure.
Yeah, watch this space. Oh, actually, we should probably plug something. So here's my plug, which is that Modo is coming to Europe. Our first market is Germany. And you'll hear a lot more from us on this in the coming months. So the team's ramping up. We're all over it, and we can't wait to be out there. Watch the space. So, Lars, thank you again for coming on, and see you soon.
Thank you. See you soon. Good talking to you.
Thank you for listening to Transmission, a Modo Energy podcast. Transmission delivers conversations from industry leaders and experts exploring energy markets and the operations and technologies related to grid-scale battery energy storage. Check out our other episodes by searching Transmission wherever you get your podcasts. Check out the Energy Academy, our video crash course on how markets in Great Britain and ERCOT work, or head to modoenergy.com to see our written research. Thanks for listening.